Hi everyone and welcome to the new video. I was looking for the high voltage power supply for my projects and I saw this high voltage generator on Amazon for less than $10 for 2 pieces. And I became curious if it really works and what can it do for this price. In this video I will assemble the generator, we'll do some fun tests and measurements and we will see how it works. It may be the first time on YouTube I will show how this budget generator can produce real X-rays. It can be fun. Without further ado, let's get into it. But before we begin, an important warning. So please be careful, and now let's get started. So I did an order on Amazon, then the order arrived, and let's see what is inside. As we can see, the package is small, there are not so many components there. First we have a PCB, all components are labeled, which is good. Then we have a high voltage transformer. We also have a transistor, a heatsink, a diode and a resistor, and practically that is it. Now let's start with the soldering. The process is easy, and as a rule of thumb it's easier to start with the smaller components, so I will first put a resistor and a diode on the board. Obviously I need a soldering iron, so this high voltage generator is cheap, but if you don't have a soldering iron your price will be a bit higher. As a next step I can solder a transistor and the heatsink. A heatsink is crucial here because the current is high. So this transistor and heatsink actually dissipates almost 8 watts, which is a lot for its size. And when the high voltage generator is working, this transistor becomes really hot. Then I can solder a power socket. By the way, this board is designed for 3.7 volts, so we don't need a really high voltage. The most tricky part here is the high voltage transformer. First you need to clean the end of the wires, otherwise they will be not conductive. You can also put a bit of solder on them. And there is a connector at the middle point, so you need to put 2 wires in this hole and then we can solder it. It may sound complicated, but it is doable. You can see the result on the screen. And last but not least, I need to solder 2 power wires. I highly recommend to use different color coding for plus and minus, otherwise it's easy to make a mistake. Usually use red wire for plus and black or blue for minus. So when you connect the wires you always know which cable go where. And that is it, let's start testing. Okay, I waited for the evening and now we are ready for the first run. Here is my power supply. As we can see I am using 3 volts and not 3.7 volts. The transistor is less hot and with 3.7 volts the arc is not really longer. So 3 volts is good for this board. And now let's turn it on. And now we can see the beautiful arc. In the first experiment we can see that air is actually conductive when the voltage is high. Usually we used to the fact that air is not conducting the electricity, but when the voltage is high it can ionize the air and go through it. And there is an empirical rule like 1 millimeter of air is equivalent to 1 kilovolt. So here I can believe the product description that this high voltage generator can produce 10-15 kilovolts because arc is 10-15 millimeters long. Also we can see that the current consumption is changing and it is between 1 and 2 amps. As a next test I will show that this arc is pretty hot and it can easily light the match. And not only the match but also wood itself. Let's see how it works. And as we can see the match is burning. And also the wood itself. Because of that I would definitely not recommend to touch the arc. But it is interesting to see how it works. Okay, now we can get the arc, and the next step I will show how to do some measurements. Because obviously it is not so easy, we can just plug a voltmeter to a 10,000 volts. The logic is simple, I will use a voltage divider. You can see a formula on the screen, it is easy. I have a large resistor, in my case it is 10 mega ohms, 2 resistors 5 mega ohms each. These are high voltage resistors, and the third resistor is only 10 kilo ohms. So as a result, 10,000 volts will be converted to 10 volts and I can just see it on my meter. Alas, this measurement is not very accurate because this high voltage generator has a high voltage but low current, and even this large resistor can decrease the voltage. So we should not 100% trust these values, but at least we should get some estimate. Let's see how it works. The high voltage generator is on, and as we can see, the value is about 3.5 volts. So actually it is about 3.5 kilovolts. And the viewers may ask why the voltage is only 3.5 kilovolts when the product description shows 15 kilovolts, why it is so low? This is an interesting question, and to answer this I will connect the oscilloscope and we will see what's going on. And to do this I will just place the probe nearby. This is the high voltage, so the inductive coupling is enough. So as we can see, the waveform is pretty complicated, and maybe there's a peak-to-peak voltage of about 15 kilovolts, but the average value is lower, and that's why our meter is showing the average of about 3-4 kilovolts. So as we can see, this generator is not providing continuous 15 kilovolts, the average value is lower. But considering its low price, it is not a big problem. Now we saw the waveform and we know how to do the measurements, and now let's go forward and get even higher voltage. Okay, as a next step I will show how the voltage multiplier works. It is an interesting device that not only converts AC to DC, but it also increases the voltage. As we can see on the screen, the voltage multiplier consists of series of capacitors and diodes. These capacitors are getting the charge and the total voltage is higher. Here on the schematic we see a quadruplet circuit. In my case, the voltage multiplier has 24 capacitors. Of course, in the real circuit we will not get 24 times multiplication, so it is interesting to test. Let's solder it and see how it works. But before we continue, I must warn you again that the high voltage can be dangerous. Do it at your own risk, only if you fully understand what you are doing. Especially with the high voltage multiplier, capacitors can hold charge for some time even when the board is turned off. So please be careful, and now let's do the test. Okay, I soldered all the components, and as we can see, the connection is simple. Here is the voltage multiplier. It is connected to the high voltage generator, and high voltage generator is obviously connected to the power supply. I know that this generator can produce up to 15 kilovolts peak, and these capacitors and diodes are not certified for that, so I am using a low voltage. I use only 2 volts as an input, as you can see. And now let's do the test. And as we can see, it works. Interestingly, the sparks are longer, but they are not drastically longer. But it's still interesting to see how it works, and the sparks are different. This is more like a lightning. In the AC mode we saw the arc, and here is more like a lightning because the capacitors first collect the charge and then it is discharged. And obviously there is at least 20 kilovolts on this wire, so I would not touch this wire, of course, it can be dangerous. And also, as I mentioned before, capacitors can hold the charge when the board is turned off. So now I'm turning this board off, and now watch carefully, there is a spark. So you need to discharge the capacitors if you want to change something. Also, it is a good way to keep the board for 5-10 minutes before doing any updates, because there are many capacitors and some of them can still be charged. So as we can see, the voltage multiplier works well. With the high voltage DC you can do some fun experiments, like for example ionic wind. And now I will show one of the iconic experiments from the 19th century. Let's get some X-rays. Okay, at this moment we have a high voltage generator and the voltage multiplier, and these two devices are enough to show a very interesting experiment, to get X-rays. There is no doubt that X-rays is one of the most influential discoveries in the 20th century. It saved a lot of lives during World War I and later, and also it is very interesting to observe the matter on the atomic level to see how it works on the quantum level. So let's get into it. The process itself is called Bremsstrahlung or braking radiation, and the idea behind is actually interesting. A charged particle, in our case it is electron, is moving with high speed, it is hitting the anode and it is decelerating and producing the gamma ray. And practically it is surprisingly simple. We only need to connect a vintage vacuum tube to our high voltage generator. It better works with a rectifier tube made in the 60s. These tubes have a large anode. And let's see how it works. So this is our schematic. At the left is a power supply. Also, we have a high voltage generator and the voltage multiplier. And the key part of the experiment is the vintage vacuum tube that I connected. Here I also have a radiation detector, and let's turn the board on. And as we can see, we immediately get a high radiation level. It works. So with this experiment we can really produce X-rays, but interestingly not all X-rays are equal. The commercial X-ray tubes have a voltage of about 100 kilovolts and we have only 10-20 kilovolts. So these X-rays have low penetrating power, and for example we cannot make an X-ray photo. As a second experiment I can show a real intensifier screen from the hospital. And as we can see, there is no glow, so the energy of these X-rays is not enough to produce the photo, and the output power of this high voltage generator is actually low, so these X-rays are detectable only on the small distance. But technically it is a good thing. For high energy X-rays we need a better shielding and more safety precautions. And of course I don't recommend to do it at home unless you fully understand the risks and safety. The ionizing radiation can be dangerous. And that's it for this video. Thanks for watching. I hope you learned something new. Press like and subscribe if you enjoyed this content. I am planning more videos about high voltage, so don't forget to subscribe. And if you want to know more about X-rays, let me know in the comments. Maybe I will plan a future video. Also, if you want to support this channel, feel free to visit my Patreon page. You may get early notifications about new videos and also access to source code for my other projects. Thanks for watching and see you next time.